My name is Casey Delaney. My lab partner is Michael Hoyak, and this is our PCB project assembly that we made for the EE309 class, the junior laboratory that's due by the 1st of August for the University of North Dakota. Before we started the project, we got all the parts we needed together. This is just a few photos we took during the process. We went out and bought a bigger breadboard so we could work with it to manufacture our product and put everything on it together. We purchased a 8 ohm speaker to use for the output for the circuit. And this is all the rest of the components we used. We had a MP3 plug that we used to plug into a cell phone. And we had all of our capacitors, our 741 op-amp chips, and our LM386 power amplifier chips. We also had our capacitors and our potentiometers that we use for our summing amp and for our volume control, and then all of our variable resistors that we use for the circuit. So we lined everything up here on the table before we started the work, and we had designed our circuit ahead of time before that is in our report. This is a few extra components we needed. We found out we were missing a few caps that we needed to modify for our frequencies. The frequency we originally wanted for our bandwidth was a little bit off, and they were causing the signals to overlap through several different filters. So we had to adjust the bandwidth filters a little bit. So these are all the components we needed before we started. All the parts we needed. Up here in the corner we have all of our jumper leads and all the extra parts that we bought. Sorry, out of order a little bit. This is the completed breadboard that we did for the circuit. On the breadboard, we had done a positive and a negative 12 volts to feed our circuit. We tried using 741 op amps, which use 15 volts. So actually, anything from 12 to 15 volts were good for our circuit. But because the power supplies we're using for the batteries, we decided to run a positive 12 volts and a negative 12 volts. So here we have the positive 12 volts and the negative 12 volts, which is the red and the yellow, and the black was our common ground for the circuit. All right. We designed our circuit to have our input over here to the a low pass filter, then through a high pass filter, and up here on the top we had the band pass filter. It all came together through a summing amp network that fed through power amp and then out to our speaker for the output for our circuit. So we put everything on the breadboard. We used the Samsung 4 phone to input a signal. We were playing one of my kids' favorites, Call Me Maybe by Carly Rae Jepsen. But we put the signal into the board, feeding through the MP3 jack, powered up the board using a power supply, and we're able to get a good signal across on the circuit. We have a link at the end of our lab report that actually shows this part of the circuit working on the breadboard. We ran on the breadboard. We had a little bit of noise and static that we had to work out before we actually did the final breadboard. But there is a link in the video that does show the actual circuit here working. This is where we're putting everything. We're transferring it from the breadboard onto the circuit board. As we transfer it onto the circuit board, we're doing it piece by piece. The low pass filter, then we soldered everything in, then the high pass filter, band pass filter, like that. That way we were able to keep all the components separate, and we weren't mixing up our design at all. This is more as we got more and more of the circuit transferred over onto the PCB board. And this was our final circuit. Once all the components that were on the PCB board, or I'm sorry, the breadboard, we transferred those all onto the PCB board, and we're ready for testing. Right. This is our final circuit that we have. We're using 2 battery cases that hold 8 1.5 volt batteries. So each one will give us 12 volts out for a positive and negative power supply. On our input here, we have it hooked up for a positive 12 volts and a negative 12 volts. We have our MP3 plug, which is our input signal to the circuit, which feeds into here. Our blue potentiometer is our volume control for our circuit. Our power feeds into the 4 capacitors here that actually filter out the circuit a little bit and keep all the noise and unwanted signal down. Then it feeds through a low pass filter down here, which has a bandwidth cutoff of about 310 hertz. We split the signal actually gets split at this point to go to the different areas. Up here we have this is the high pass filter, which was designed to bypass all frequencies above 1150 hertz. The low pass filter here in the middle passed all the frequencies below 310 hertz. And on the top here we got 2 op amps. We have a high pass circuit first on the left hand side, which feeds through to a low pass circuit on the right hand side. The high pass circuit had a 5960 hertz bandwidth, and the low pass had a 630 hertz bandwidth. All 3 of the signals from the filters go to the summing network here, provided by these potentiometers, where you're actually able to adjust the different frequencies for the 3-band equalizer. All these come through to this op amp, 741 op amp, which works as a summing amp. Everything from the summing amp goes to, this adds all the signals back together, and then it's fed through a power amp here at the bottom by the big blue capacitor. The power amp is an LM386, which is designed to boost our circuit up high enough that it's able to feed our speaker actually and drive our circuit. So this is the final breadboard here. These are for the lab partners. This is a 3-band equalizer circuit for Casey and Michael. And the next video link will show this circuit actually working. Thank you.